I am Karima Mundell Thomas.
And I am Latoya Shiraya.
We will be guiding you through CSEC Math. This week, we're going to be looking at constructing frequency tables.
Let's get into it.
Yes, I'm so excited.
All right.
Now, as we said, we're looking at constructing frequency tables, but we have a situation here, Latoya, where Mark and John are having a disagreement about types of data, the different types of data.
Right.
And you and I are being asked to help Mark and John.
But like mobile data?
No, girl. We're talking about statistics.
Oh,
stay on course,
Right.
girl. Stay
Right,
on
right,
course.
right,
So we're
right.
talking about
Right.
statistics.
Yeah.
So we're looking at data that is collected from weather observation.
Okay.
You conduct a survey. You issue
Right.
some questionnaires. That
Yeah,
type
man.
of data. So
All right.
I'm going to ask you to just help us out here.
Okay, so with data, when you collect data, it could either be qualitative or quantitative. When we talk about qualitative data, we talk about descriptive words. So ice cream, the color, the flavor. And then when we talk about quantitative, we talk about numerical representations. But then when we talk about quantitative data now, it can either be discrete or continuous.
Okay, and
Right.
I would like our students to pay attention to this diagram on screen,
Nice.
which basically summarizes what you have said earlier.
Yeah.
So we see the data being either qualitative or quantitative, and as you said, quantitative can either be discrete or continuous. But I want to hear some more about discrete and continuous data.
All right, no problem. When we talk about discrete data now, this data can only take specific values. These are usually countable and they may or may not be whole number values. So when we think about the number of fingers or toes that we have, very specific. So I have 10, you might have 11 or 9, but it's very specific. When we talk about the number of students in the class, very specific, or your
Yes.
shoe size, is either you wear 8.5 or 9. You can't wear 8 3/4 in size. Very specific.
Okay, so just to wrap our minds around that, we said that the number of students in each class can only take whole number values.
Definitely.
Because we don't have half a child.
Problem.
All right. And shoe size, we're saying though we can have a half size, it still only takes specific values.
Right.
So we can't wear 8 1/4,
No.
8 7/8,
Well, if you do, you'll have
8
to buy
9
the
10.
10 size or the 9 size.
Okay,
but-
got you,
right.
got you. All right, tell me about continuous data now then.
Now, continuous data can take any value within a range.
All right.
Yeah? This is a type of data that is usually associated with some sort of physical measurement. Measurement is the key word here.
Oh,
So when you talk about length or your weight or your height,
okay.
so as you know, some persons, some families, some parents, what they do is to have a wall or a door or a column where they measure the children at each level and at each age rather, and this time you might be 17 centimeters and 2 millimeters.
17 centimeters, that sounds weird.
Yeah. Just say it.
Those measurements sound
Just
off, but
say.
I get the point that you're trying to make. All
Right.
right. So, this is interesting, and I want to test. I really want to test. So, let's just put it out there. You've done a wonderful job, and I want to see if I've grasped what it is that you have said just now.
All right.
So, and I want to see for students. So, students, pay attention. We want to see if you are able to tell if these data that we're going to be talking about, if they are discrete or if they are continuous. So the first one, number of pets that your classmates have. So based on what you said, Latoya, if I can only get specific values, then it's discrete.
Right.
And when I think about number of pets, we don't have any alpha pets or
I would
three-quarter
like to
pets.
hope not.
So I would go with discrete. I wonder if our students got that. Let's see if I'm right. Yes.
Discrete indeed.
All right, so you look like you're doing a good job teaching me. So
All right, what
start.
about this one? The length of strips of ribbons. Strips of ribbons.
So you talk about continuous data being something that's usually associated with measuring. So I'm looking here and I see length of strips of ribbon. So I think that this is continuous.
All right.
Am I right? Am I right?
Continuous indeed.
Okay.
All right, what about this one? Time taken to run a 100-meter race.
This one is interesting. So normally, and I love to watch Olympics, normally when a race is being done, I don't know if you normally watch the timer, and you will see that it's showing fractions of a second. And I remember this one race where there was a tie, and in order for them to decide who came first and who came second, they actually had to break down, the time.
Milliseconds.
Or even smaller than that. So I'm going to go with continuous for this one. Am I right?
Yes, you are.
All right. I actually feel bright.
Number of children per family. I think this one is pretty easy.
Similar to the pets situation here, because we don't have half a child, yeah?
I hope not.
So definitely we can go with discrete.
Discrete. And finally, age in years.
I know you're trying to trick me,
No,
age.
man.
So age in and of itself, I think that's continuous because we can talk about age in years, months.
Right, because right now I'm 16 years, 2 months, 2 weeks, 3 days, and 6 hours.
How many seconds?
2 minutes,
how many?
53, 54, 55
All
seconds
right.
old.
I get the point.
Yes.
But this says age in years.
Right.
So we're now restricting it to specific values. And based on what you said, that sounds like it's discrete. So once we have now said age in years, then it's discrete.
Definitely.
So you must be this one here, the 16.
No, man, the one in the basketball.
Oh, all right,
Right?
fine.
Yes.
Discrete it is. So I think I've done a fairly good job, and I do hope that our students out there got this part correct. Now let's move on. Now John is conducting a survey. He's a student council rep, yeah?
Yeah.
And he's conducting a survey in his class. He wants to know how the 20 students in his class rate the customer service at the school's canteen.
Very important.
And they are asked to rate on a scale of 1 to 5, where 5 is the highest rating. And you see, because you're such a good teacher, I can tell already that this is discrete because
Gold
they're
star.
not going to give me any 1.5, 1.3, 1. Not those ratings. It's either 1, 2, 3, 4, or 5. Now he asks each student to write their rating on a sheet of paper. He then collected them and wrote them down on one sheet.
Right.
All right. And these are the ratings that he got. So, you know, Latoya, I'm looking at this, and I don't think John can make sense of what's happening right here.
It's kind of looking a little bit jumbled.
Yeah, it's not yet organized in any way. So right now, John can't have a report to carry back to the student council meeting.
No. You have to organize it a little bit. This is looking a little bit like what we call raw data.
Raw data,
Right?
that's the word, raw data. So this is data that has not been organized or sorted in any form.
Right.
So John needs to do some sorting, no?
Right.
Yeah. So let's help him. He can sort using frequency tables, yes? Now, a frequency table tells the number of times an event, category, or group occurs. In other words, how often this event took place. And don't be fooled by the word event. Whatever it is that you're observing, we refer to it as an event. So if you were looking at height, weight, number of students, whatever, rating, we consider that to be an event. So your frequency table, if you look on screen, should look something like this, where we have the event, category, or group on one side, and the number of times that each occurs will be written on the other side. And we can refer to that, Latoya, as the frequency
table.
Beautiful. Now, the frequency table can be useful for describing the number of occurrences of a particular type of data within a set type. So right now, John can't tell how many students gave the canteen a rating of 3.
Right.
Data is too jumbled as it is, but in the frequency table format, he will be able to do that. Also, the frequency table can help us to identify any trends that there may be and, you know, to compare data between data sets that are of the same type. So he can make comparison. Which rating got the most? Which rating did more students select versus which one did the least number of students
And we're
select.
not saying that you can't get all of that information from the raw data. We're just saying that using the frequency table makes it easier.
Right.
You don't have to spend the time counting up every time, but you can just look at your frequency table and just pick up the information quickly.
Very important. So we're saying it's difficult but not impossible to do it when it's raw.
Right.
Excellent point. I'm glad you pointed that out. So let's help John with his frequency table, shall we? And I see this word, tally. We have never said that word since we started.
No, but I think we all know tally. That's from primary school.
All right.
When you draw your little strokes and counter.
All right, fine. All right. So I'm going to allow our students to just watch what's happening on screen as we mark off. And we're marking off just to ensure that we don't miscount. So we don't count a number twice or don't count a number at all. So just watch, students, as we're completing our tally. And for each one, we're seeing one stroke come in. All right. So we won't spend a long time here. I think you are getting the idea. I want to pause here, though, and notice that for the number 4, the rating of 4, we're seeing here that the 5th stroke actually was drawn right across the 4 that were there before. Are you seeing that, Latoya?
Yeah, man, looking like a nice like a picket fence.
Yes.
Close it off.
And this is important because what this does is that it helps us when we are finished with our tally to actually count in groups of 5.
Which is pretty easy.
Which is
5,
pretty
10,
easy.
15, 20.
Right. Yeah. All right. So that's basically the idea here. So I'm sure that John is now ready to make some judgment about his data. Now, from the tally, we can quickly fill in our frequency.
Right.
Right. And that's basically just writing the actual number that corresponds with the tally marks.
Right.
Good. So we can see 1 popping up.
4,
5,
8,
2. And 2.
Right.
All right. So this is pretty manageable stuff. So yeah.
And just by looking at the tally, I mean the frequency table, I can see that this canteen not going on badly, man.
True. Not
Seems
going
like
on
I could
badly
get some
at all.
lunch from this canteen.
Yes, definitely.
All right.
So one last thing that John needs to ensure that he does before he starts to make any judgment, he needs to ensure that the total frequency corresponds with how many students he...
Very important.
Right. So he has to ensure that when he adds the numbers in the frequency part of the table, that it actually comes back to 20, which is the number of students that he actually
started out with.
Right, that participated in the survey. We ensured that our student, John, we ensured that he had the total frequency that corresponded with how many students. Now, the frequency table here on screen shows the number of pets owned by 15 students in a grade 10 class.
All right.
And the table is up, and your duty now is to find the value of X. Yes, your duty.
My duty is to find the value of X. All right, not a problem. All right, so from looking at this and the mere fact that you said, remember your total from the last time, I know that all the number of students must sum to 15. So when I have completed my frequency table, all the number of students should sum to 15.
All right. So how many do we have here then?
So I have 2 plus 7
2
plus
and 7, yeah.
1 plus 2.
Added to 1, added to 2. How much is that?
A number? 12. 12, right.
All right. And what are we supposed to do with that 12?
So seeing that I should have 15 students, I can account for 12. I'm thinking I'm going to take the 12 from the 15.
Makes sense. Yeah. How much that gave? Let me see if I can
Call
check.
yourself the bigger number. Beat your chest.
Really? Okay, so
3.
15 subtract 12 gives 3.
3
Right
indeed.
along. So we know that the value of x is 3. Now let's look at this other activity. We have a set of values here showing the number of newspapers sold each day at a local shop over 10 days. And again, we can clearly see that this is discrete because we
Yes.
don't sell half a newspaper.
I would like to
All
not
right.
think.
So I'm looking at this though, Latoya, on a serious note, and I'm seeing the least number of newspapers being sold is 18.
Right.
And the greatest number is 25.
Right.
But I'm wondering, with the least sale being 18, is there a need to represent on my frequency table numbers that are, or sales that are less than 18?
Well, seeing that we didn't sell 17, 1, 2, 4, 15, all from 1 to 17 being sold would be 0. I don't think so.
Yeah, I don't
we
think
already
so
know that.
either.
We could just start at 18.
All right, so let's look at what this frequency table would look like. All right, so clearly want to remind our students that the least number of newspaper sales was 18 and the
Right.
highest is 25. And so we are accounting for every value that is in between 18 and 25.
Right.
All right, just want to put that out there. So ensure that you account for every value from your least to the greatest. Now, activity 4. Max has a garden.
Max don't like my boy.
I was about to say that, but you
Yes,
took it
ma'am.
from me. So
Farmer
Max has a
Shreya
garden.
here.
He measures the heights of all the plants in his garden. Their heights to the nearest centimeter are given below.
All right.
Now, this is continuous, not true?
Yes.
Height, no?
Yes.
Yes, so we're talking about continuous data. But note the question says that he rounded or he wrote them to the nearest centimeter.
Right.
Now, we want to construct or create a frequency table to show this data. But Latoya,
Wow.
remember we said you must represent every value from your least
Yeah.
to the greatest.
And I'm seeing the least to be 7 centimeters here and the greatest to be 48.
Now imagine if I'm going to have to draw,
man.
construct a frequency table and I
From
need
7?
all the way to 48.
Oh, no. Oh,
That is
no.
a very long frequency table, you know?
And then we also said, though, that the frequency table helps us to organize the data. So I don't think writing from 7 to 48 is actually... So I think...
I have the solution. Don't say another word. I have the
Okay.
solution. I
All
have the
right.
solution. I have the solution. I think we need to
right.
group this data.
Definitely.
Yes, so in order for us to capture all of those values, we
Right.
need to just group the data. Group
them up, cluster them up.
Yes.
Yes, ma'am.
But you know, before we get to that though, there are some things about grouped data that we have to explore with our students
All right.
before we construct Max's frequency table.
I think
So
that
let's-
makes sense.
Yeah, let's talk about a few things. So class intervals.
Interval from right here so to right there. So that giving me... that's what intervals seem like to me.
All right. So the class intervals are the subsets
Yeah.
into which the data is
Is-
grouped.
yeah.
All right. And we have to be careful, Latoya, because we have to ensure that how we do our class intervals, an observation should fall in only one class. So
And
we
we
can't
talk
have an
about-
observation falling in more than one of these groups.
And we talk about observation. Is another word for event or the values,
All right.
the grades, whatever is,
Beautiful.
the data is about.
So talk to us about these intervals here, Latoya.
All right, so for me, I like rounded numbers, and I realized that the smallest number was 7.
Yes.
So I said, okay, let me do an interval from 1 to 10 and then 11 to 20. And notice I start at 11 because you said that each event, observation, data, value must only be in one class. So if I
Right.
end my first class at 10, then I can't start my second class at 10 because then now you will have one
If I have a
event
value of
possibly
10.
falling in more than one class.
Got you,
So I'm starting
got
at the next number.
which is 11.
Right, and I'm
Alright.
sure you can see a pattern here. We're
Yes, we
picking up a
can.
pattern.
We can.
Right?
So how many class intervals do we have here?
5.
5.
Five
All right.
class intervals.
So these are the intervals that Max will be using for his observations
Right.
when he measures the heights of his plants. All right. So let's take a look at class limits.
You know, when I hear the word limit, I'm now thinking of limit. I'm now thinking about my credit card limit
Show
that
off.
I need not pass. Right. So the limit is the least and the greatest.
Okay.
I'm going to so I spend $0 too. I will not say, and I will not pass that limit.
Okay, well,
Right.
when I think of limit, I think of when I was younger, you know, and your parents said to you, say, all right, this is your gate, and you can't go beyond down there, so down the road, so they set a limit there.
Okay.
Or beyond that point, up the road, so they set
Okay.
a limit there.
Okay,
So
yeah.
that's what comes to my mind.
All right.
So let's see what we have here. Now, the class limits may be defined as the minimum value, or in other words, the lower limit, and the maximum value or upper limit that the class interval may contain.
All right.
So with that definition, can we identify the lower and upper limit of each of these class intervals?
I wonder if the viewers at home can.
Students, can you? I hope so. Let's see. So I'm looking at this class interval, 1 to 10. And this looks to me like 1 is the lower limit.
Lower the
and
least.
10 is the upper limit.
Right.
Yeah, so I think this is fairly easy. So we can watch our limits coming in. So for each class interval, the starting value is our lower limit, and the value that ends the class interval is our upper limit. And I do believe our students are catching on to
I
this
think so
part,
too.
don't you?
Easy man, easy peasy.
Yes, I think so too. All right, so let's talk about Max again. So Max is measuring the height of his plants. And though he recorded to the nearest centimeter, he recorded the heights to the nearest centimeter, what would happen if he had a plant with a height of 20.6 centimeter? Which class interval would that fall in, Latoya?
All right. So this one takes a little bit of reasoning for me now. So
All right.
20.6. It can either be in the 11 to 20 group because it's 20, or the 21 to 30 group.
You sure? But it's
But
20.6.
That's what I'm saying now. 20.6, if I was supposed to represent it on a number line, would be closer to 21.
Oh,
Right.
you had me panicking there for a
No,
moment.
man, I was just saying that it could either be one of the two.
So it's
and I
in
would
between 20 and
Right,
21.
that's what I'm saying.
Okay,
right.
all right, fine.
So I would put it in the 21 to 30 class because it's closer to 21.
All right, so it's in between 20 and 21, but it's closer to 21, so it
Yes.
falls in that class.
Yes.
All right. So you kind of wrapped up a little because look like you saw this question coming. Where would the height of 20.3 fall?
All right, same thing. It's in between 20 and 21. But if I were to represent it on a number line again, I would see 20.3 being closer to 20. So I'd put it in the 11 to 20 class.
Interesting. So I'm looking here and we got two values. Both between 20 and 21,
yeah.
but they fall in two different classes.
They did?
That sounds to me like we have a boundary. We
Yes.
have a boundary line, not true?
Yes,
we have
ma'am.
a boundary.
Just like when your mother tell you don't pass your limit, but you know you can go look oops right here, so.
That
Yeah,
sounds like
man.
you are an unruly child. I will not condone that. But class boundaries, nonetheless, let's talk about them. So I'm looking here, and I want to zoom in on the monitor here. I'm looking at this class interval 1 to 10, yes? And the next class interval is 11 to 20. So I'm noticing that there is, we can call it a gap for now,
Right.
between 10 and 11.
Right, and that gap would represent a lot of values that we are not representing now, like a 10.1, 10.2, 10.3, and so on.
Right, so we have several values in between. Now, I am thinking that the halfway mark between those two values, so we're talking about 10 and we're talking about 11.
Right.
What's halfway between 10 and 11?
And I like halfways, it's fair. You get half, me get half.
Yeah.
And the halfway between 10 and 11 would be 10.5.
10.5,
Right.
good. So it means, therefore, that the boundary for this class, the upper boundary,
Right.
is 10.5.
So any plant that falls within the range of 1 to 10.5 would be in that first class.
Oh, well, actually 0.5. So I'm going to talk about the lower boundary now. I'm
okay.
going to talk about the lower
Okay, okay.
boundary. So we talked about 10.5 being the halfway mark, which means that 10.5 would be the lower boundary
Boundary
for this class interval 11 to 20.
Right.
All right. So based on that, it seems to me that for my lower boundary, I am supposed to subtract 0.5 because here is my limit. Okay,
Right.
here is my limit. And my lower boundary is going to be 0.5 less, and my upper boundary is going to be 0.5 more. All right? Hope we got that, students. So let's look at our screen as we see the marks coming up on the table. So again, lower boundary 0.5 less than the lower limit.
Right.
And upper boundary 0.5 more than the upper limit.
So any plant for max now that is as a height of 0.5 up to 10.5 would be in the first class.
That's correct.
All right.
That's correct. All right. So when we look at this, so remember that 10.5 is the halfway mark.
Right.
All right. Now, as we look at this, I want to make an important observation here because I'm noticing that the upper boundary for this class interval is the lower boundary for the next. And I see the same thing happening. Upper boundary for this second class interval is the lower boundary for the next. Sound to me like this is giving me that kind of continuous effect, not true?
So it's like I meet
Here
you
is
here and hand you the button and you continue on with where you're going.
I see. I like that
I feel
analogy.
like a 4x1 race kind of vibe.
I like
you know?
that analogy. But class boundaries are useful, we said earlier, for continuous data. And we can
Right.
see that coming out because we're
Right.
talking about
So like,
halfway mark.
That give me a histogram vibe. I don't know.
Girl, you looked at you took a peek.
I didn't.
All right, so we're talking about histogram. It is useful
Right.
for histogram, and I want our students to actually look at this histogram and notice that it is our boundaries that are being used for the histogram. So where the first interval ended at 10.5, the second one began at that very same point. And so we get these bars being joined together, and that's what a histogram is, a special bar graph that has our bars joined together.
By their
All right.
boundaries.
I feel brilliant today.
Me too.
All right, so let's
I'm
run
sure
to class
students
width.
at home are feeling brilliant with us.
All right, let's talk a little about class width. Width. So it says here that it tells the size of the class interval, or in other words, how many values are in a class.
How wide it is?
So when I look
How
at the
much?
first one, 1 to 10, if I count on my fingers, 1, 2, 3,
You want me to write them on the board for you?
5. You can write them for another activity in the meantime, but I'm counting on my finger first. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 values are in this class. But Latoya, I really can't go count on my finger for everything. There must be an easier way to find the class width.
And this is math. There's always an alternative.
So let's see what the alternative is. Oh, looky here. 20 subtract 10 actually gives us 10.
10.
Let's look at the other one. 30 subtract 20 give us 10. And I'm seeing something here, Latoya, because
11
what if
minus 1 is also 10.
Oh my goodness.
21 minus subtract 11 is also 10.
Right. So I'm seeing here that if I want to find the class width, I can use my upper limit. So I subtract upper limit 1 from upper limit 2, or I can use the lower limit. And we could also use the boundaries too.
Right,
so let's just do one. So the boundary here would have been 10.5. I hope they're seeing my hand. Right, that 10.5, and the upper boundary here would have been 20.5.
Yes.
20.5 subtract 10.5 is 10. Oh, Lord, this is so interesting. So, students, you have so many options available to you. All right, so ensure that you get a shot of this. We would have discussed it. So, we can use upper or lower limit 2, subtract upper or lower limit 1. And, of course, we can also use the boundaries.
And I want to point out that the 2 and the 1 doesn't necessarily mean the first and second rows, but it would have been the 2 representing the class interval that would have come after. So if we're at, say, class interval 21 to 30, that would be our 1 in this case, and 31 to 40 would have been our 2 in this case.
Okay,
right.
Very good observation. So let's talk about class midpoint. Midpoint. And I'm stressing the word midpoint. Yes. What comes to your mind, though?
You know what? I remember as a child, when my older cousin was say, you love in the migs a big people, in the miggle.
I tell you, you were an unruly child.
No, I wasn't. I was just trying to be a part of the conversation.
Okay. What comes to my mind is the halfway mark. Not true? Yes. Halfway between 2 points. Yes?
Yes.
So in the middle, as what you said, but boy, you were really unruly.
I wasn't.
So let's see if we can talk about this. So I notice you have some values there. So we have the first class interval represented on our white board. So you have written 1, 2, 3, 4, all the way to 10.
Right.
And those are the values that we found in our first class interval. Where's the middle of that?
All right, so this is what I'm going to do for ease.
All right, go ahead.
I'm going to say, I'm going to know each one I circle from the left, I'm going to circle from the right till I get to the middle point,
all right? Go ahead. Go ahead.
So I circle one here, one there, one here, one there, one here, one there, one here, one. Oh.
Yeah, man, continue.
Well, one here.
So where did the middle fall?
Well, the middle fall right in here, so no.
Oh, halfway between 5 and 6. What's that?
Well, I don't want to make any guesses. So what I'm going to do is, I'm going to say 5 plus 6 divided by 2. That's what I'm going to do. I don't want to make any
Okay, but if we were on a number line, we could also identify that halfway mark and know what to put there, right?
Yes,
Yeah.
5.5.
5.5. But Latoya, I don't want to have to do that for every single class interval. I'm going to write out all the values. That will there must be an easier way. Please tell me.
You tell me.
All right, so I like what you did though. Let's see what's happening here. So we're saying that the class midpoint, we can actually calculate it using our lower class limit and the upper class limit of the class interval for which we're finding the midpoint.
Okay.
So in this case, we're using the first class interval, whose lower limit is 1,
right,
and upper limit is 10. And so 1 added to 10 gives
11.
11. Good. And then now I'm going to be finding that halfway mark, yeah? Finding what we said up here, the mean, the arithmetic mean.
Right.
So I've added 2 values. So to find the mean, I need to
divide by that 2.
Divide by 2. And that will actually give me 5.5.
So whether I count from one end till I get to the middle or I use the upper and lower limits, I will get the same answer, right?
Yeah.
Cool.
Yeah.
I love math.
Yeah,
different
me too.
approaches.
That's right.
Fun.
Same destination.
Yeah,
different route. So let's take a look at what Max's frequency table would look like. So I brought back the values, the heights that he got.
Right.
And just bringing up the values so you can see. You can always take a screenshot of this.
Right.
And
so this is saying
explore.
that he had 2 plants with a height between 1 and 10. He also had
Inclusive.
3 plants with a height between 11 and 20, 7 between 21 and 30, 8 between 31 and 40, and 4 between 41 and 50.
Right. I remember these were already rounded to the nearest centimeter. Right. So I think it's time for students to get a CSEC question.
Well, that's what we're preparing for.
That's right. So I'm going to ask them to take a screenshot of this. This will be their homework or we'll do it. Let's see.
We can start it.
Let's see. We can help them through. So a class of 24 students threw the cricket ball at sports. The distance thrown by each student was measured to the nearest meter, and the results are shown on screen. All right, and we have taken another shot. The values, the raw data is still there.
Right.
And so our students in TV land can ensure that they capture this and go ahead and answer these questions. First, you are to fill in the class intervals and the frequency, and you're also being asked to state the lower boundary, which we would have discussed today, for the specific class interval 20 to 29. So that's it for CSEC Math. Yes,
just getting
time flies when you're having fun. So that's it for CSEC Mathematics.